Hello and welcome to section 10.1. We're talking polynomials in this unit. And we're going to start off with adding and subtracting polynomials. Okay, we've been working a little bit with polynomials in the fact that a lot of things we deal with have just expressions have one term, or we did work with combining like terms, and that's the main thing that we're going to be doing today. But as always, we're going to start off with a few definitions. So term, we've talked about it before, and really what term means is the coefficient variable and exponent combination. Okay, now what I mean by that, coefficient is a number, integer that's being multiplied. It doesn't have to be an integer for that matter, a real number that's being multiplied by a variable, and a variable again just being a letter or some symbol used to indicate an unknown value. And then an exponent is, as we talked in the last unit, the repeated multiplication of that variable in this case. We could have an exponent maybe on really anything. So, there could be an exponent on a coefficient if we had it, but most of the ones that we'll see won't. And the coefficient will just be either a whole number or a fraction. So, if we're looking at a polynomial, maybe it's just a polynomial, maybe something that looks like 2x squared plus 3x minus 5. Okay, that's an example of a polynomial, and the terms are the coefficient, variable, and exponent combinations. Okay, and we've worked a little bit with that in the past, and we're going to continue with that at a little deeper level. So a polynomial itself is just a multi-term. So a multi-term expression. The word polynomial comes, can be split into two different words, meaning poly, or being poly, meaning many, and nomial just means terms. Okay, so it's something with many terms. This is a polynomial. There's 3 terms in it. There doesn't really have to be more than one term, but most of the ones that we're going to deal with do have more than one term. Okay, so when we're looking at polynomials, we're going to look at standard form first. And standard form of a polynomial is just a polynomial written written in descending exponent. You can't read that. So written in descending exponent order. Okay, that's what it means for a polynomial to be written in standard form. And descending exponent order just means that I have my highest exponent first, and then my next highest exponent, and then my next one. And there's a really formal way to write that out, but I don't want to do that because it's just a bunch of numbers or just a bunch of letters with different exponents and different things like that. So or in fact I will. That's not a bad thing. It's just it gets ugly, so bear with this. So say we have our first coefficient, and then our variable, and our first exponent, and then we're going to say plus a to the 2 x to the n minus 1, which means that if you had if this was maybe the 5th power, this would be the 4th power, or the next power that's available. So then plus a 3 x to the n minus 2, and we're going to end at a 4 plus x to the n minus 3. Okay, just meaning that as you see it, those powers keep going down. They don't have to go down by 1, but if there are, if it's available to have exponents go down by 1, that's the way that you should write it. And we're going to get a better look at that as we go here. So the degree of a polynomial is the highest exponent. Okay, so it's the highest exponent, and that exponent has to be on a variable, so we'll put that on there, on a variable. So in this example here, even though it's a very generic example, the degree would be n, because n would be the highest exponent there. In the one up above, that's a little bit better luck, and this is written in standard form because you have x to the second power, and this is actually x to the third or first power, and this would actually be the same as having x to the 0 power. Any constant, you can still put a variable on there, but raising it to the 0 power makes that just go away straight to 1. Okay, and that's kind of how it's written, but again, that's a very ugly way to write it. So we just write it just like that without the x to the 0 on the end. So the degree of this one up here would be 2 because the highest power is 2. So that's going to be something that we're looking for, and it's something that's fairly easy to find if you ask me. So the leading coefficient is the last thing we're going to talk about, and the leading coefficient is just the coefficient on the first term. So that's kind of how it makes sense to me, is that leading just means the very first coefficient. Like if you're in a race, the thing that's leading is the thing that's out in front. Okay. The only thing there is that it must be written in standard form. I'm going to put that, and that's very important. Must be in standard form. Okay, because I could rewrite this a different way. Like say I wrote it as maybe 3x plus 2x squared minus 5. So that's not in standard form, okay, where this one is. And the leading coefficient is 2 because it's the first coefficient on the on the leading term, on the highest exponent term. But whereas this one, you might say, well, the leading coefficient's 3. It's the very first number that's there, but it's not written in the correct form yet, so we can't really say that. All right. So let's go ahead and look at, we're going to be starting off by classifying polynomials. All right. So when we're classifying polynomials, we're going to classify them by degree and number of terms. Okay. Now, it's something that seems difficult, sounds difficult, but it's actually really easy. Let's say we have an example of, well, let's just go with our one that we had up above. 2x squared plus 3x minus 5. Okay, so that's our example that we're working with, and it's already written in standard form, so that's nice. The first thing that you'll always have to do is to write it in standard form and then try to do, then classify it, as we say. So first off, we're looking for degree. Now, degree is just the highest exponent. Okay, the highest exponent is 2. So if the exponent is 2, it fits in right there. So you would say that this is a quadratic. Okay, quadratic. And then number of terms is the other thing that we'll classify it by. And then this one, there's 1, 2, 3 terms. So 3 terms fits into trinomial. So this is a quadratic trinomial. All right, and that's just what we call it. All right, so a small part of today will be about classifying polynomials, and then the rest of the time we're going to be adding and subtracting polynomials. This will also ask for the leading coefficient, these problems down below, and you'll just want to say LC for leading coefficient equals, in this case, it's 2. All right, and that would be what our answers are going to look like for these. Wow, there's 9 problems down there. All right, we're going to have to bust through them real quick. So here it even tells us, write the following polynomials in standard form, then classify by degree and number of terms, and identify the leading coefficient. Sounds like a lot to do, but it's really not. Let's go ahead and see what it looks like. In this first one, I have a power of 3 here before my power of 2. That's not okay. So we just rewrite it. And the way I rewrite it, if you remember like combining like terms, okay, I think of this as an entire chunk. Okay, this plus x to the third. And I'm just going to move that out in front. I think of all these things as just being chunks. Okay. And make sure you tag those signs, the leading positive or negative sign with those. All right. So if I move that out in front, I have x cubed minus 4x squared plus 3. Okay. Now that's not too bad. So classify it by degree and number of terms. The degree is 3, so it's cubic. So we say that it's cubic. And then number of terms, there's 3 of them, and it's a trinomial. Trinomial. And then the leading coefficient equals, there's nothing in front of the x cubed, so we just say that that equals 1. You're never going to have a leading coefficient of anything less than 1. Okay, it can't be 0. Sorry, yeah, it could be negative though, but it just can't be 0. So here, to rewrite this one, we're going to say, all right, that 15x cubed, that should go in front. So let's say we have 15x cubed plus x. Okay. Now the degree is 3. Degree 3 means cubic. I think there's a lot of cubics on here. No, not really. All right, so it's cubic. Number of terms, there's 2. 1, 2. Remember, terms are separated by plus or minus signs. So 2 terms means binomial. So it's a cubic binomial. And the leading coefficient is 15. All right, we don't say that the leading coefficient is 15x cubed. Okay, we just say the number that's multiplied by the variable. All right, next one. And so here we have, well, it's already in standard form, so that's good because we have x squared, x to the first, and then there's no x on that one. And so the leading degree, or the degree, is 2. So we have degree of 2 is a quadratic. So it's a quadratic. 3 terms is a trinomial. And then the leading coefficient is -7. That negative has to go with it. That's important. Okay. Why don't you pause the video and try the next 3, and then I'll do the last 3 with you. Okay, welcome back. Hopefully you had a chance to get those done. Okay, all 3 of these, if you didn't notice, they're all in standard form. This one at the end is kind of weird, but we'll talk about that when we get there. Okay, here, there's a degree is 2. So the degree of 2 is called quadratic. There's only 1 term here, so it's a monomial. See in my little chart there, 1 term is monomial. Mono means 1. So there's a monomial, and the leading coefficient is 8. All right. Next one, we have, it's already in standard form. X is actually to the first power, so the degree is 1, and a degree of 1 is linear. So that is a linear 2 terms binomial. Think of bicycle. And a leading coefficient, -12. That's the number being multiplied by the first variable. All right, last one. There is no degree, or, this is the same thing, like I said before, as x to the 0. Okay, whenever there's no degree, we get this constant. So it is a constant. There's only 1 term, so it's a constant monomial. And then the leading coefficient, well, there's only 1 number there, so it's 18. All right. Not too much work there, but it was a little bit different. Let's look at this next one. Now, there's something weird going on in this next one. I have a 17x cubed and a 2x cubed. just like combining like terms, I need to do that. So that's going to be a 19x cubed plus 4x plus 3. That tells me it's a cubic trinomial, like tricycle, with a leading coefficient of 19. Okay. This next one here, I just need to rearrange. Okay, I need to put the x squared term in front. So it's going to be a negative 13x squared. Make sure you carry that negative with you. Plus 4x minus 11. So it is a quadratic. It's a trinomial, again, with a leading coefficient of negative 13. The reason we like to use trinomials is because binomials are boring, and anything smaller than that is also boring. So that's kind of why it's overused. So here we just want to rearrange these. So 42x squared, keep that negative with it. And even though there's not a plus sign on that 13, we know it's a positive 13. So it is a quadratic. There's two terms, so it's a binomial with a leading coefficient of negative 42. So now you should have a good concept of what it is like to classify trinomials, and that's really the only new part from today. If we go ahead and turn the page, we're going to be adding and subtracting polynomials. Now what that really means is just combining like terms. All right, so you know that thing you learned way back, I think it was like section or unit 2, okay? And really I kind of have a rule here, and if we're adding, if the operation in between is adding, all you have to do is combine like terms, CLT, combine like terms. If you're subtracting, if we're subtracting, like this one here, all I want to do is distribute the negative into every term. So I'm going to say distribute the negative. And then after you do that, combine like terms. Okay? So you're seeing a lot of overlap in things that we've already learned and what we're doing today, which is awesome. Anytime you can catch that overlap, it definitely helps you and makes things a lot easier. So even though there's parentheses around this, it's addition, okay? All I want to do is combine like terms. And I want to write it in standard form, just so you know. So I look for the highest power, and the highest power here is x to the third, so we're going to rewrite that one first. 3x to the third. And then I want the next highest power. It looks like x squared. So plus x squared. Now for the x's, I do have two of them. So we're going to say there's one and there's one. Negative 4 and negative 3 is negative 7x. And then I have constants over here, just numbers that don't have a variable. So 3 and negative 5 would give me negative 2. Okay, I'm not going to ask you to now, classify the polynomials and all that. I just want to know that we can add and subtract these. Okay. So let's go ahead and look at this one. Whenever I have a negative, I always rewrite it using a positive. And here's what I mean. This is the distributing the negative part. So I have negative x squared plus 3x minus 4. I just rewrite the first one. Okay. Now I'm going to turn that negative into a positive. Or in fact, I'm just going to distribute it and write whatever sign this first term is going to be. Okay, so it's a positive 2x and I'm making it negative. So that's a minus 2x. I'm going to make that x negative. Minus x. And since that's already a negative, I'm going to make it positive. Plus 1. Okay? And now, that's at 2x squared. But now all I'm going to do is combine like terms. So I have x squared. That's a negative 1 and a negative 2 gives me negative 3x squared. I have a x and x, and that's a 3 minus 1, which is going to be plus 2x. And then I have a negative 4 and a positive 1, gives me negative 3. And that's my answer. Pretty neat, huh? And more importantly, it doesn't take a whole lot of time like those other things we've been doing with exponents. Okay, but we worked that hard back then so that now is a lot easier. That's why we do that. Okay, so here I am subtracting, so I'm going to rewrite it. Negative 3x squared plus x plus 8. Distribute that negative. X squared becomes negative. Negative 8x becomes positive. And a plus 4 becomes a minus 4. Now I just combine like terms. X squared, negative 3 and negative 1 gives me a negative 4. And that's an x squared. Positive x, positive 8x gives me a plus 9x. And an 8 minus 4 gives me plus 4. Okay. So let's get this last one done, and then I'll have you try the last two, and it'll be real fun. Here I'm working with addition, so all I want to do is combine like terms. I have an x to the third. That's the only one I have, so that's going to just be a 5x to the third. Now I'm looking through here for x squareds. Found one, and it's the only one, so negative 3x squared. Now I'm looking for x's. Got one there and one there. Negative 2, negative 6 is a negative 8x. And then I have a minus 1 and a minus 2. Gives me minus 3. Okay? Not too bad, huh? Go ahead and pause the video. Try the last two problems. Okay, welcome back. Hopefully they worked out for you and you didn't get too frustrated over them. Okay, I'm going to start off looking for my highest power. I see an x squared there. No powers there. There's an x squared. So my first one's going to be x squared. Okay, let's go ahead and call those out. I have a negative or a positive 4 and a negative 5. That's going to be a negative 1x squared or just negative x squared. Okay, x's, I have one here and one here. Negative 2 plus 1 is a negative x. And then my constants, I have a negative 9 and negative 7 gives me a negative 16. So not too bad. Okay, hopefully you got that one. And let's go to the last one. It is a subtraction problem, so I will rewrite it. Okay, I'm just going to rewrite the first one as it is. You know, some people ask me, well, why don't you change the order there? Because it's not a big deal. I'm just going to be looking through there for the different terms that I need, and then I'll rewrite it in the proper order at the end. So distribute that negative. Bam, bam, bam. So it'll be a negative 3, a plus 9, x squared, and a plus 2x. So I'm looking through here. X squared seems to be my biggest one. I have a 7 and a 9. That's going to be 16. X squared. X's. 2 and 2. That's 4. And negative 3 and negative 3 is negative 6. And there we go. That's the last problem of the day. Good luck on the mastery or the application practice mastery challenge. Okay. Hopefully you guys learned a little bit today. A lot of it, remember, is just combining like terms, so it is a little bit easier. But the classifying polynomials part could be new, so make sure you pay attention to that. If you need to rewatch the video or ask me for help, feel free to. Thanks. Bye. Okay, for this unit, we're going to be looking at some funny cat clips. You know, a while ago we had the cute puppy clips, and I just want to see, be politically correct here and involve the cats as well. So number 5, to start off our countdown, number 5 is tread kneading. Okay, kneading is what cats do when they claw something. Let's go ahead and take a look.
Should I put it on?
Oh god, this is gonna end really poorly.